Okay, just one more minute and then we'll continue. Alright, we'll continue now. Okay, so we'll go on to the next lesson now. We're back to quadratics for the moment, and we're looking at completing the square. So let me just a little bit of background. Let's say I give you something like this: x plus 2 squared plus 3, and I want you to simplify it. Well, you would expand. So this would be x plus 2 times x plus 2 plus 3. And what's the reason for that? Well, because plus 3. Well, because a squared is a times a. So x plus 2 squared is x plus 2 times x plus 2. Let's multiply it out. X by x, x squared. X by 2, 2x, 2 by x, 2x, 2 by 2, 4 and 3. So this would be x squared plus 4x plus 7. Now, what's the verb that describes going from here to here? Yeah, we have this verb, it's expand. So, going from here back to here, that's called completing the square, which is the name of the lesson. And that's what we want to learn how to do. How can we go from this answer back to this question? It's not as difficult as you might think. So just write this little bit down and we'll have a look at an example now, how this process works. Okay, so in a moment now I'll do an example. Actually, do you know what? I'll use this one as an example because we know what the answer should be. The answer should be x plus 2 squared plus 3. So let's see how we can do that. Yeah? Okay, let's have a look. It's really not that difficult. Just watch carefully. So what we do is we write down our bracket and our square. So we know for this it'll be x plus a number plus a number. We need to figure out those two numbers. The first number is very easy to get. This number here is always half of this middle number to begin with. So this number here will be half of the 4, which is 2. Okay? So far, so good. And now how do we get this number? This number, watch carefully, will be the 7 at the back minus whatever the square of this number is. So the square of 2 is 4. So that's 3, isn't it? Well, that's actually what it was. But that's it.
What is it before we have the 7? Do we just put...
Big 3.5. Yeah. And we'll do an example of that in a moment. When you write that down, we'll do another one. Okie dokie. Yeah. Right, next one. So this will be x plus some number squared plus some number. Well, this is obvious. Half of 16? 8. And it'll be 71 minus 64. 7. Okay, let's do another one. 10x plus 2, we'll say. Okay. So, what's my first number? 5. And then it'll be 2 minus 25, which is minus 23. Are we getting the idea for this? Yeah. So let's do no, let me give you one to do. I'll make it x squared plus 4x plus 13. Just give that one a go, please. So this will be x plus 2 squared, and then 13 minus 4, 9. We get the process? Yeah. Right. Now, on to something a little bit harder. Try this one for me. Let's stick in a fraction. X squared plus 9x plus 105 over 4. That's right. Yeah, done. Actually, keep them as fractions instead of decimals. Okay, got this? So, it'll be x plus 9 over 2 squared, and then it's 105 over 4 minus what? What am I minusing? 81 over 4, because it's the square of this, which would be 24 over 4? 6 then, yeah. Plus 6 is what you have here. Okay, now, next example. What do we do if there's a number in the front? So if we have something like, say, 5x squared plus 30x plus 43. A little bit of vocabulary actually. Bit of vocab here. Yeah, well, this one here, this is the coefficient. And in this case here, the coefficient is 1. So there's a special name for this when it happens. Does anyone know? Well, they're both quadratics, but this is a special type of quadratic. So it's a something quadratic. Nah. simple quadratic, happy quadratic maybe, or yeah, no. In English, what's the prefix for 1? Mono. So if we could try and make mono an adjective. Not monoquadratic. No, stick with mono. No one wants to try making mono an adjective rather than a prefix? Monatical, mono. Like what are we going to go with? Monial? Oh, I like it, but no. Monoial. No, not this. Wonderful. I love it, but not this. Not this. Anything else? Come on. No? Monaco. Yeah. No. Monic. Yeah. A monic quadratic. I do like a monocle quadratic. I like this one. Anyway, the examples we've done so far were monic quadratics, but we need now to look at one that's not monic. So, back here, does anyone have any ideas on how I could deal with this guy? Because the problem here is the 5. Take the 5? Take the 5 out, yeah, take the 5 out. So we have 5, big bracket, 43 over 5. But then you realise we can just repeat the process. So this would be 5 bracket x plus 3 squared, and then it's 43 over 5 minus 9, which is minus 2 over 5? Isn't it?
Yeah.
One step left. What's the last step here? Multiply. So it's 5 x plus 3 squared minus 2. Now, once you write that down, I'll let you try one. Try this one for me. 3x squared plus 30x plus 67. Try that one when you're ready. Okay, let's have a look at this guy. So, firstly I should take the 3 out. X squared plus 10x plus 67 over 3. That will be 3 bracket x plus 5 squared, and then it's 67 over 3 minus 25. Is 8 over 3, is it? Minus 8 over 3? Okay. And lastly I'll multiply by 3. X plus 5 squared minus 8 then. Next. So we've learned how to complete the square, but we need to see, what is something useful we can do with it. Now, if it helps, quadratics. If you didn't know this, if you were to draw a quadratic, it has a shape like this, or it has a shape like this. So there's this point here, which is kind of an important point, which is called vertex. It's also called the minimum or maximum. It's also called the turning point. And that's something we're going to try and find now. So let me go back to my first example. Goodness, all the way back here. So if I just go back to my first example, if I said y equals x squared plus 4x plus 7, it's not clear what the smallest value of y could be. You know, could the smallest value of y be minus 10? Could it be minus 20? We don't know. But if I write it in this form, it actually becomes quite clear what the smallest possible value of y could be. No. 3. Because if you really think about it, look at what's happening here. No matter what number I pick for x, this part here must be positive. Why? The square. Yeah. So in fact, what's the smallest I could possibly make this? 0. I could make it 0. I could make this 0, and that's the smallest I could make it. So the smallest value of y has to be 3, because my expression is like this: y equals 3 plus something positive. So the smallest value of y is 3. Not only that, I know when this will happen. For what value of x will this happen at? Minus 2. Why did you pick minus 2? Yeah, it's because that's what will make this part here 0. So in other words, minus 2, 3 is the point which is lowest on the graph. So if you want to think of this as like a rule, if I have y equals x minus a squared plus b, the vertex point is at, yeah, what would be it here? A, B. So this is why we like to complete the square, because it lets us find the vertex. So let's just run through these together. So this one here, the vertex is at minus 2, 3. Where's the vertex here? Minus 8, 7. Here? Yeah. And here? Minus 2, 9. Here? No, actually. Minus 3 and minus 2. Because the 5 has no effect on where this would be 0. This one here? Yeah. So it's very easy. Now, but there is an issue here. Sometimes the point, the vertex, is a minimum, and sometimes the vertex is a maximum. And does anyone know how we can know which it is?
Depends on positive or...
It depends if it's positive or negative. So, in fact, in all of these examples, they're all beginning with a positive, don't they? Yeah, they're all positive. They're all positive. So all of my examples are this shape. But if I had an equation like this, then it would be that shape. So your vertex would be a maximum instead of a minimum then. Okay, so this is why completing the square is useful. It lets you find the vertex. Okay. Now let me give you a hard one to try. I'll scroll down. So here's a quadratic. Y equals minus 9x squared plus bx plus c. And I tell you that this crosses the y-axis at minus 569, and it has a vertex at, I'll just make this a bit clearer, y equals minus 569, and here the vertex is x equals 8. And I don't tell you what the y is, I only give you half of the vertex. So believe it or not, I've given you enough information to find the b and the c. I want you to think very deeply about this, how we could find the b and the c. I'll give you a little tip. The c is the easier one to find. So start with, you can maybe even see it already. So find the c first, and then think about how to find the b. We'll try this one now. Okay, let's have a look at this one. This is very, very difficult, very difficult. I think some people can see how to get the c. So how should we get the c? It's minus 569, yeah. Because it crosses the y-axis at minus 569. So you know when x is 0, y should be minus 569. So if you have that substituted in here, you get minus 569 equals 0 plus 0 plus c. Okay, so we have the c at least.
Then you replace the x by the 8.
One sec. Right, well, okay, now the real question, how can we get the b?
You have the x, which
Yeah.
you replace minus 8 squared
Mhm.
plus b 8
Yeah.
minus 569.
Yeah.
You equate it to 0 and then you find b.
Yeah, no. Because what you're doing there is you're acting like the x equals 8 is a root. You don't know that the y is 0. You know? I didn't tell you the y. In fact, if you look at all my examples over here.
I mean, there's an example like b squared over 2, b over 2 squared.
You're getting closer perhaps. Do you notice here in my vertex, none of my y's are actually 0. So I couldn't do that. Where's my question gone? Where'd it go? Oh, there it is, hang on.
Is there a formula like minus b over a and that's minus b squared?
No. What should I do next? Go on. I should take the minus 9 out, yeah. X squared minus b over 9x plus 569 over 9. Because I took minus 9 out. Yeah. Now what good is doing that? What should I do next? Say again, yeah? Very good. I should continue completing the square. So this is minus 9 bracket x minus b, a half b over 9, which is b over 18, squared, plus something. And I actually don't care about the something. because I have everything I need right here. Where will the vertex occur? The vertex will occur when x equals b over 18. But I actually know where the vertex occurs. Where does it occur? When x is 8. So therefore, b should be 8 times 18. And that's how you get the b. Now you see, that's a hard one.
So wait, for example, if I complete this square and I have like equation, let's say x plus 2 squared.
Yeah.
I'm just giving a big
Yeah.
x plus 2 squared plus 3.
Yeah.
So the minimum, the turning point basically is going to be the number right after x plus.
Yeah.
What is the number is that the turning point?
Yeah, well, change the sign of it. So if you had x plus 2,
You make it
minus
the turning point
2.
become minus 2.
Yeah. Yeah. Did anybody manage to get that?
I got 124, but I don't remember how it was. 144, but I don't remember how it was.
What is 8 by 18? Is it
It's 144.
48 by
144?
Yeah.
Okay.
And the number that stands on between, what's that?
Say again?
Let's say like I have x plus 2 squared
Mm-hmm.
minus 3. The minus 3, what is that called?
Oh, that would just be the, again, the vertex is the x and the y. So the two numbers together is called the vertex.
So the negative 3 would be the y.
The y value, yeah.
But it would be 3, not negative.
No, you don't change the sign on the y one.
But
Yeah.
change the sign
On the x one,
sign
yeah.
of the x.
Yeah. Yeah.
I did it like this.
Yeah.
I made it minus 9 for the bracket x plus 8 the whole square minus 559, and I multiplied 9 into 16 and I got 144.
I wonder if you got the right answer by accident.
Yeah.
It's kind of sounding a bit like that.
Sorry.
Yeah.
I don't know, but I think it was the formula like minus b over a squared.
Oh no, there's more to do on this. More to do. We haven't done any formulas yet. Yeah. Okay, next. 8x squared minus 80x plus 205. Eight x squared minus 80x plus 205. Right. You. What is your lucky number? 7, okay. So I get a positive, alright? If I put in minus 4, still positive. Okay? Minus 1, still positive. Okay? No matter what number I put in, I think the answer will always be positive. Let me just put in my lucky number here. Still positive. Okay? So it doesn't matter what the number is, it will still be positive. But I would like to prove this. I would like to prove no matter what the value of x, you can put any number in for x, I want to prove that this will always be positive. That's what I want to prove. So how can I prove that? Well, let's see what happens if we complete the square. So this will be 8 bracket x squared minus 10x plus 205 over 8, which will be 8 bracket x minus 5 squared, and then 205 over 8 minus 25. Is that 5 over 8?
5 over 8.
Yep, okay. So that would be 8 x minus 5 squared plus 5. Now, I'm actually finished. I've actually proven that it's always positive. Because the reason is because 8x minus 5 squared is bigger than or equal to 0. Obviously, because it's a square. But it could be 0, couldn't it? Like, when would it be 0? If I picked x as 5, yeah. 5 is obviously bigger than 0. Obviously. And it's obviously not 0. So if I was to add these together, which is what I'm doing here, then indeed it's bigger than 0. And not equal to 0. I can't get it equal to 0. Because the 5 always makes it at least more than 5. Yeah? So I've proven that it's always positive. I sometimes see these in the exam. They'd ask you, here's a quadratic, prove it's always positive. Yeah, if you do that, you would need to write a little bit more, because you're thinking the delta is less than 0. But that could be always negative, if you had something like this. So you would have to write a little bit more at the end, to prove that it's not always negative, that it's always positive. But sometimes students do it this way as well.
Does that take more time?
No. But we haven't done delta yet. We haven't done it yet, so.
Oh, that's it.
Yeah. Okay, write this one down, please. Now, in the exam, you do have to write something at the end, okay? Because there is a mark for this at the end. Now, you don't have to write exactly this, but you do have to write something. So this question might be something like might be like 3 marks. It might be something like this. All right, write this one down, please. You got it?
Yeah.
Got this? Yeah. You look so tired. Is the Red Bull not working? No? 5 over 8. There's a Starbucks on Stephen's Green that's open 24 hours. You weren't there last night, were you? No? Because I do discover, as time goes on, my students like to, stay up with their friends in Starbucks until 2, 3, 4 a.m. Not this. No. Okay, you have this? Yeah. We have 10 minutes left, so for the last 10 minutes you can try get started on these. So again, we'll keep it simple, first and last in each. First and last. So AX, AZ, AW, AU, AD, AL. First and last. Can I close this now?